Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of line angle formulas, and I will throw in a few examples as well since the concept is so short. Line angle formulas, otherwise referred to as skeletal or stick figure, stick, whatever you want to call it, basically is the concept that whenever you have a carbon, it's represented by a line, and we look at the ends of the line, either the beginning or the end, and each of those are considered to be one carbon. So here would be one carbon, and here would be another carbon. A corner where two lines meet also is a carbon. So in this little stick figure, we got one, another one there, and a third one there. Okay? Alright. Other heteroatoms like nitrogen, oxygen, fluorine, sulfur, whatever it may be, bromine, you got to actually write those in. Hydrogens, though, only if they're attached to one of those heteroatoms would you draw the hydrogen. Otherwise, the rest of the hydrogens are assumed to be there that would complete this octet rule, if you remember from chemistry, having that full outer valence shell. And that's basically it. There's not much to it. It's a quicker way of writing things. You'll see a lot of textbooks use it, so don't panic if you see it. Let's check out a few examples. First one we're going to look at is here, 3-butanol, and basically the condensed formula would be 4 carbons because of the prefix BUT. It's the alkane, butane, right, which is just a hydrocarbon, and it's got the suffix -ol, which makes it an alcohol. Just a quick little nomenclature review, IUPAC review. And the line angle would be 1, 2, 3, 4 carbons there. Let me number them for you. And then on the third one, because of this 3 prefix, you got to put a hydroxyl group to make it an alcohol. All right, let's look at something a little bit more complex. 3-isopropyl heptane. All right, here's the condensed structure. Heptane is 7 carbons. 1, 2, 3, 4, 5. Ooh, I did short myself one, didn't I? 1, 2, 3. Oh no, there's a suffix of 3. So 4, 5, 6. So 4 through 6 are in this parentheses because of this subscript of 3. And here we have the 7th carbon. So there's your heptane. And there's an isopropyl group. If you remember, this is the isopropyl group. Okay? And if you were to put a line for each one of those, this is basically what it would look like. Alright? Let's look at another one here. Why don't you take a second and see if you can do it. 2-ethyl-3-dimethyl octane. Okay, so pause the video and try it. Okay, hopefully you paused the video and tried it. If not, you give up too easy. Let's see what's going on here. We have octane, so that's 8 carbons. So here's 1, 2, 3 along the main chain, 4, 5, then 6 and 7 are right here because that's subscript of 2. And then there's your 8th carbon. And then there's an ethyl group on the 2nd carbon, looks like, and 3, ooh, I forgot the 3-3, right? Because for each substituent, you need a numerical value. So 3,3-dimethyl octane. So that means we have the 2 methyl groups are here, dimethyl, and it wasn't on the 3rd, was it? It was on the 5th, so I need to change that. 3,3 to 3,5, sorry. It's getting late, and I've made videos all day since 5 a.m. It's now 1 a.m. Took a couple naps, but putting in some work. All right, so let's recap from the top. 8 on the main chain, ethyl group, 2 methyls on the 3rd and the 5th carbon. So 8 main chain, ethyl, there's 1 carbon right there, and then there's the other carbon right there. Okay, dimethyl on the 3rd and the 5th, right there and right there. All right, pause the video, try this one on your own. 3-bromo, 5-T-butyl, 2,7,8 trimethyl nonane. Hopefully you've studied your IUPAC nomenclature by now and you're pretty good at drawing compounds. If not, that's okay. Just practice, watch a video, look at the handout. Okay, so hopefully you attempted this problem. Let's take a look at it. Here's the condensed formula. We have 9 carbons on the main chain. Let's see if we can count those out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. And then there's a methyl on the 2nd, 7th, and 8th. So there's 2, 7, and 8, right? And then there's a T-butyl group, which is basically a carbon that's got 3 methyls surrounding it. And then that's attached to the main chain as a substituent. So in the line angle formula should be similar. We have a 2,7,8 methyl, good, trimethyl because there's 3. And then there's a bromine on the 3rd carbon, and I didn't mention that on the condensed formula, but it's right here. And then there's the T-butyl group represented by that cross-like shape there. All right? So that's basically it with line angle formulas. If you do enough of these, they become second nature, and they should become second nature because you will see them throughout the year of organic chemistry for those of you that have the pleasure of taking an entire year. All right? So practice, practice, practice. I hope I've eliminated any of the confusion you might have. Thank you, and have a nice day.